path, there is a robot. On M times n grade, the robot is initially located at the top left corner. Grade the robot tries to move to the bottom right corner, which is grade M minus 1 and n minus 1. The robot can only move either down or right at any point. So n minus 1 is basically the most left portion, the most right uh, position of each row, and n minus 1 is basically the most bottom last. So that's this value here. Given the two integers m minus m and n, return the number of possible unique paths that the robot can take to reach the bottom left corner. The test cases are generated so that the answer will be less than or equals to 2 times 10 to the square of 9. So this is our example 1, our starting point and our finishing point, and we have n is 3, which is we have 3 rows, and n is equal to 7, so we have 7 columns, and it says that we have 28 output as 28, which means that we have 28 as our possible unique paths. So let me copy and paste this to get to our bottom row from our starting point. So let's keep in mind this, that's what we need to output. So example 2, we have n equals to 3 and n is equals to 2. So our rows and column 2, we have output 3, because we can either, so for example, well, in this case, this is basically this portion's our grade, and we start from here. We can either go down, right, down, and this is our finishing positions, and that's 1, or we can go down, right, or down, right, down, and that's 3 different ways that we can get hit to here. So we can solve this. This can be quite mathematically complex to solve manually. Well, it may be or may not be depending on your mathematical level skills, but we can solve this with a 2D. Well, this is a 2D dynamic. This is the 2D dynamic programming problem. Let's make an array to store values of current positions, also let's initialize the first the first column and row to have the value of 0 of 1 in its position, 2 in its let's initialize it to have the value 1 in their positions in order to be able to proceed with solving the rest of the problem. So we can do that by continuing dp equals to, let's make a list, and let's put 1 as the value, and then make multiply that by our columns, and so for, and also for every I in our row in the range of, oops, not the range of, no, for every value in the range of n, which is our row. So now let's move on to our loop iteration through our creator. So that will be done by for I in the range, oops, there again, the range of m, no, from the second value of m, which will be at the index of 1, and also from j in, oops, range of 1 to n, which will be the second value all the way to the last value. So now let's add the current values to get the current value positions value in our DP array, DP I j, let's add the current value the value of the current, wait, the left, the value on the left of the current of the, hold on, let me take this. And the value of the up above. So that will be done by left. So that will be I minus 1, and let's move this. This will be done by I minus, no, j minus 1. So this is the column, and this is the row. So now let's move this. So now let's put this into code. So that will be dp I will be equals to ij will be equals to dpi dp I minus 1 dp, oops, no, and then j, and then plus dp I and j minus 1, and that's basically it. That's all. And this is what so this is basically the output. Return our dp, and then let's just put this inside it. M minus 1, it should be the most right. So this will be a new row here, and no, the row, the last row, so which will make it any of these possible three ones, and this one, this column n minus one, which will be the last value of the row. Boom. I mean column, and that's this. Boom. That's how we get that n minus one, and that's it. Let's see if it works. Boom, and it's been accepted without any syntax errors. So our time and space complexities and space complexities are both O of m times n for space complexity. For space complexity, our indexes will be stored for time. Our indexes will be iterated. And that's it for this problem. Let's submit it to see if it's going to pass all cases. And it's been able to pass all cases. It says 18%, but this isn't too accurate. Last time I did it, it was about 84%. And that's it for this problem.